Hi, let's discuss quicksort algorithm. I already discussed some sorting algorithm like selection sort, bubble sort, which comes under brute force approach, insertion sort, which comes under decrease and conquer approach, merge sort, that is divide and conquer approach. Quicksort is another sorting algorithm of divide and conquer. So there are three steps: first divide, then conquer, next is combine. Suppose one array is given A, L, R, L for left, R for right. These are the index. Then in divide, we'll partition A, L, R in such a way that we'll find A of S. And A of L to S minus 1 should be less than A of S. Also should be less than A of S plus 1 to R. And in concur, we'll recursively call A of L to S minus 1 and A of S plus 1 to R. We'll partition in two parts. One part that is before A of S, another part that is after A of S. Next is combine. Because these somewhere are already sorted. Every time we are doing partition, this A of S is already sorted. So no work is needed to combine them. Now the entire array is sorted. So in divide stage, what we are doing, we are dividing the array in such a way that A of 0 to S minus 1 should be less than A of S, also should be less than A of S plus 1 to A of N minus 1. So this left part is less than A of S and this right part is greater than A of S. Now this A of S is already sorted. Next we need to sort this left part and right part recursively by using quicksort. So what is the difference with merge sort? In merge sort, during the combine phase we are doing the sorting, while in quicksort during the divide stage we are doing the sorting. Now this A of S is already sorted. So after every call one element will be sorted. So during the divide stage we are doing the sorting and there are no work left for combine stage. So that is the difference with the merge sort. Here the entire work happen in division stage, while in merge sort the entire work happen in combine stage. When we are combining, at the same time we are doing the sorting in case of merge sort. Here when we are dividing, at the same time we are doing the sorting. Let's discuss the quicksort algorithm. Input one sub array a 0 to n minus 1 defined by the left and right indices, means this is our L and this is our R. One array is given, index starting from L to R, and what will be output? A L to R, and now it is sorted. So if L less than R means left index is less than right index, S partition A of L to R. So this partition means you are calling another algorithm and from there we'll find the split position. This S is the split position. So that I'll discuss in next lecture about the partition algorithm. Here I'm just discussing the quicksort algorithm. So here we'll call another algorithm, another function, and from there we'll get the split position. Next we'll call again quicksort starting from A left to S minus 1. Again we'll call quicksort algorithm A S plus 1 till R. So here we got a position S and we'll do quicksort of left part and we'll do quicksort of right part. This is the left part of split position, this is the right part of the split position. So this partition algorithm was developed by C.A.R. Hoare. He is a British computer scientist. In 1960 he developed this algorithm and after 20 years in 1980 he got Turing Award for this algorithm. So what exactly we are doing in partition algorithm? We'll now scan the subarray from both end, means from left to right, also from right to left. So what we are doing in left to right scan? In left to right scan, we'll take one index pointer I and that will start from the second element. And we want all the elements which are smaller than pivot should be at left side of pivot. So what we'll check? We'll skip for all smaller element than pivot and we'll stop at the element which is greater than or equal to pivot. Means I pointer will stop if it found any element which is greater than or equal to pivot. Next, right to left scan. In right to left scan, we'll skip all the elements which are greater than pivot and will stop when we will find any element which is less than or equal to pivot. We can use a index pointer j. From left to right we can use I, from right to left we can use j. And in left to right scan we will stop if we find a element which is greater than or equal to pivot, and right to left scan will stop if we will find the first element which is smaller than or equal to pivot. After both scan stop, there are three chances. First situation, if I is not crossed j, means I value stop before j. We simply exchange a of I with a of j and resume the scan by incrementing I and decrementing j. Now I stop at a point where this element is greater than P and here this element is less than P. Now we'll swap A of I with A of J. This is first situation. Second situation, if it crossover, means I crosses the J. In that case, what we'll do, we'll simply exchange pivot with A of J like this. Here you can mark I crosses the J. So you can swap this P with A of J. Next, third situation, if both I and j stop at same point. If there is an element which is equal to pivot, then I equals to j. So thus we have a summary partition with the split position S equals to I equals to j. And this case we can combine with the previous case like crossover. So what we can do, we can simply exchange pivot with A of j. So here these two positions we can exchange. In today's lecture, I discussed quicksort algorithm and what we'll do in partition algorithm. In next lecture, I will discuss partition algorithm with one example of quicksort. If this lecture is helpful for you, please like and subscribe. Thank you.